Hello, my name is Lane Peer, and today I'm going to be giving a presentation on my composite of choice, which is carbon fiber. And I'm going to be getting into some things as far as manufacturing processes, some finished products, and ultimately overall what carbon fiber is. So getting right into it, what is carbon fiber? Carbon composite is material made from two main ingredients: thin strands of carbon fiber and a plastic resin that binds them together. The carbon fiber provides extraordinary strength and stiffness, while the resin holds everything in shape, providing forces across the structure, and the result is a material that can be up to 10 times stronger than steel while in tension, yet dramatically lighter than both steel or aluminum. You'll find carbon composites in everything from commercial aircraft, engineering applications, aerospace, high performance vehicles, sporting equipment, and musical instruments. It is also used for production of windmill blades, natural gas storage, and fuel cells for transportation in the energy field. Carbon fiber on its own is just a bundle of extremely thin filaments, each one far thinner than a human hair. These filaments are strong when you pull on them lengthwise, but they can't hold a shape by themselves. That's where that resin comes into play. Those fibers are embedded in a polymer matrix, either a thermoset resin, which hardens permanently when heated, or a thermoplastic resin, which can be remelted, reshaped, when reheated. The matrix locks the fibers in position, protects them from damage, and distributes loads across the entire structure, so no single fiber bears too much stress on itself. Some of the advantages of carbon fiber will include its high strength and durability. Itself is stronger than steel. Carbon fiber can withstand heavy loads just heavy loads in general without deformation. Corrosion resistant, so unlike metal, carbon fiber does not rust or corrode when exposed to harsh environments. Its aerodynamic benefits: due to its lightweight nature, it enhances speed, efficiency, and fuel economy. Its flexibility in design, so carbon fiber can be molded into complex shapes for custom applications, and its enhanced aesthetics. So the signature carbon weave pattern does give a pretty premium look. Often it's left exposed in luxury vehicles and high performance parts to just kind of show off that look in general. So getting into how carbon fiber is made, it goes through polymer precursor preparation, typically made from pan or pitch. It is then stabilization. The precursor fibers are heated to oxidize and strengthen them. Carbonization, so the fibers are further heated in an inert environment, removing non-carbon elements and increasing the strength. Graphitization, further heat treatment improves the crystalline structure, enhancing mechanical properties. Getting into surface treatment, which then improves bonding between fibers and resin, and then sizing and weaving. Carbon fiber strands are woven into sheets or formed into unidirectional layouts for various applications. This will be one of the manufacturing processes for carbon fiber. It is the pre-preg molding process. These are the steps as far as it'll go through for the manufacturing process in general. It'll start off with material preparation, so it cuts the pre-preg carbon fiber sheets to the required dimensions needed. It'll then go through a mold preparation, applying a release agent to prevent the sheets from sticking. Layering, placing carbon fiber sheets into the mold with precise alignment. You'll then get into vacuum bagging, so sealing the mold with a vacuum bagging system to remove any of the trapped air, and then it'll go through the autoclave, which applies controlled temperature and pressure to cure the resin and bond the carbon fibers together. Post curing, so after it'll get out of the autoclave, it'll go through additional heat treatment, ensures optimal strength and heat resistance, and then finally finishing. The cured part is trimmed, polished, and coated with a UV protection coating if needed. These will then finally get into some of the applications of this specific manufacturing process. You'll get aerospace, a lot of that in various engine components, including fan blades, where it's lightweight and thermal stability, improved thrust to weight ratios, and fuel efficiency. You'll have automotive body panels such as fenders, bumpers, or hoods. Some of the images below will show that. So you'll have that exposed carbon fiber look. That'll be a little sleek. You'll see that often a lot of times on high performance vehicles. And it is a favorite as far as car modifications. It just overall improves the look of the vehicle, the aerodynamic aspect, and the weight overall. There is a huge weight saving factor when you do start replacing these body panels, and overall, like I said, it just improves the aesthetic of the car. You'll have high performance sporting goods, which will include tennis rackets, golf clubs, anything from bicycles to snowboards, hockey sticks, and bats. One of the other manufacturing processes for carbon fiber will be the compression molding process. That'll start off by preforming carbon fiber sheets. You'll take those pre-cut sheets of carbon fiber, which are then placed into the mold. You'll apply heat and pressure so that when the mold is closed, the high temperature and pressures are applied. Finally, then the curing process. This part is left in the mold until fully cured, and then demolding and finishing. Excess material is trimmed, and the final part is polished or painted. Some of the applications that'll follow the compression molding for carbon fiber will include wheels. So carbon fiber wheels also kind of just improves that aesthetic, the weight of the car, the handling as well. You'll have automotive and motorcycle interior components. So that picture in the bottom right corner will just include a front picture or kind of like a face shot of a motorcycle and how it's outer body is just kind of included with those carbon fiber materials. You'll have structural supports in aerospace and marine industries. So you'll see boats that'll use carbon fiber hulls, and you'll have some aerospace or like commercial applications to where they're used on wings to improve weight, balancing, and fuel economy as well due to its improved weight. And then this will be my references, and we're excited.